This is the lesson 8.2 visual summary. So we're talking about grocery carts. So try to get a visual on how the carts stack together. One kind of goes inside the other. So one grocery cart is 42 inches in length. But when we have two grocery carts, they're nested inside of each other. So the total length for two carts is 52.5 inches. So first thing we want to do is try to complete the table. So this should say carts. So when I have 0 carts, total would be 0. When we have 1, it's the whole 42 inches. When there were 2, they told me it was 52.5 inches. So if I look from here to here, the total increased by 10.5 inches. It didn't double because, like we said, a lot of the cart was tucked into this cart, and there was just a little bit extra, the 10.5 extra inches, kind of where the handles are that you hold on to. So if I add a third cart, it's only going to go up by, again, another 10.5. So that would be 63 inches. And then when I add a fourth, it's going to go up by another 10.5. So now it would be 73.5. And again, it goes up by 10.5 to 84. So they want me first to explain why two nested grocery carts do not have a total length of 84 inches. Because 42 plus 42 would give me the 84. But the reason is, remember that most of the second cart is inside the first cart. Remember, it said they're nested together, so the one cart fits right inside the other cart. So only a little bit extra shows when you stack up all those carts. So what's the additional? After the first, it increased by 10.5 inches. So we're going to try to write an expression to represent X number of carts. Here's how I'm going to do that. I'm going to kind of talk my way through this. If I can put it into words, I'm going to maybe do that down here. Then I can figure out my expression. So the first cart is 42 inches. But every cart after the first increased the length of all the carts by just 10.5. So I want to figure out how I can change this to an expression using X to be the number of carts. So the first cart's 42. So it's always going to be 42 plus, and then it's 10.5 inches for every single cart, but not the first one, because the first one was 42 inches. So all the rest of the carts, it increases by 10.5. So all the carts, but not the first one, add 10.5, but the first one is 42. So we always see, so I can't really draw pictures very good, but let's just say this is my little handle. Here's my cart. Here's the wheels. So we see all 42 inches of the first cart. But then when we add the next cart, the handle's there, but most of that cart tucks in, and it's just this little bit out here, this 10.5 that shows. And same with the next cart added after that. It tucks way in, so only what's showing is another 10.5. So when I have 3 carts, there's 2 groups of 10.5. 3 minus 1. If I had 10 carts, I would see all of the first cart, 42, and 9 of the carts would add the 10.5. So if I want to graph this, if I'm going up to 5 and there's 20 lines here, remember this is X and this is Y. Here's my independent, this is my dependent variable. So if I go to graph these, here's my Y, And here's my X, and I could put labels, number of carts, and this is the length in inches. And if I want to go up to 5, I'm going to start with 0 here. 1, 2, 3, I'm going to go every 4. That's 1, 2, 3, 4, 5. And I need to go up to 84, and there's 20 lines. So 84 divided by 20 is, if 80 divided by 20 would be 4. So I'm going to go up by 4. So that would be 4. Here would be 8, 12, 16, 20, 24, 32, 40, 44, 48, 56, 64, 72, 80 would be here, so the 84 would just be one line above. So we can graph these. 0, 0, 1 cart is 42, 2 carts is 52.5, 3 carts is 63, 4 carts is 73.5, and 5 carts was 84, which would be one line above. Okay, so would I connect or not? I can't have part of a grocery cart, so I would not be connecting these.